Okay. Um, so I just handed back the midterms, and I gather that you all have no questions. I wanted to say this about copying. If you see something in a paper and you think you'd like to copy it, there are certain rules that make it okay, and certain rules that are not, that are going to make it not okay. If you take something from a piece of paper, and you want to quote it, what you do is you put it in quotes to show that the words are not yours. You put the citation next to it, and then you might even introduce the quote by saying, um, in the words of John Maynard Keynes, the outcomes of an unstable currency are evil. And then what you do is you have it end quote. So in the words of John Maynard Keynes, and then quote, the outcomes of an unstable currency are evil, end quote. And then what you do is you cite the Treaty on Monetary Reform from 1919 by putting it in an angle bracket so that it says Keynes, and then in the reference it has the Keynes in an angle bracket, you know, in the literature cited, and it says the Treaty of Monetary Reform 1919. So you might use that to support some assertion that you have, like um, the standard volatility of the price of Bitcoin relative to the US dollar is a sign of an unstable currency. And, in the words of John Maynard Keynes, the outcomes of an unstable currency are evil, right? People want currency to be a store of wealth. So they don't want, you know, like, I don't know if you guys are familiar with Bitcoin, but last week it had a very high volatility because people were speculating in it. So it wasn't a really very good store of wealth. So when you make the citation properly and you make the quote properly, it's legit and it's fair use. And that's okay. On the other hand, if what you do is take something out of a piece of paper or paper that you've seen, and you put it in your narrative, you don't quote it, you make it look like it's yours, and your professor Googles it and says, hey, you took that right out of a paper, then that is going to hurt your grade, because your professor will say, that's plagiarism, and that's wrong, so don't do it. So we never had this discussion about plagiarism because it hadn't come up before, but in one case, you know, I found it and I said, well, let's just explain it and try and make it so that this doesn't happen again. And people should all understand how to properly cite sources and quote other people's words. So if what you want to do is take the thought and put it in your own words and then cite, like for example when you're doing a historical survey, and you might say something like, oh, this thing with bitcoins is terrible and the outcomes of unstable currency are generally considered poor, then you could cite Keynes and his Treaty on Monetary Reform and maybe 10 other economists who feel the same way. And you don't have to quote any one person. And now it looks like you're just as erudite as if you quoted somebody who was a dead economist. So I say it's okay to quote as long as you make it clear when the words are not yours. And when you do quote literally, you probably just want to limit it to one or two things that sound profound, right? Because otherwise you're just taking your paper and filling it up with other people's words, and that's not good. You know, there should be some thoughts in there that are your own. Hey, George. Good. I got your, actually, not so good. Got your paper?
Oh yeah, I'm actually
Raul, I got something else here. I didn't grade. Because this was the first. So is everybody sort of clear about fair use? When you're quoting fair use and you cite properly and you put it in quotes and you make it clear that somebody else's words, that's okay. What about sort of like basic concepts like, I don't know, um, what is this called? The outlet power control system, right? If you said to me, outlet monitoring is not new, and then you cite, right, Kilowatt and the seven different other products that are out there, NXP is not new, and you cite all the XP papers, and transmitting monitor information to the computer is not new, and you cite all the Arduino plus XP and the Raspberry Pi plus XP, and but what is new is my use of power line digital data transmission with whatever, a computer, for doing outlet control and monitoring. But then if you said, but X10 has it too, then I'd say, okay, if X10 is doing it, then where's the new part? So I need to identify what's new, and I do that by citing prior work and showing where your contribution is relative to the prior work. So whenever anybody wants to see your presentation, cut to the punchline and say, my contribution is in the area of, and you might say something like home automation and outlet monitoring and control. This is not a new topic in the field, but it is a topic of current research, and what I pose is something a little different than what's been done in prior times, whatever that may be. So it's very important to identify what's new. In the context of what's been. So that's kind of what the literature survey is about. How many people had more than 10 references in their literature? I have George and Suresh, Raul. Yeah. At this point, I think it's time. You need more than 10. Right? This is a readings course, which means you have to be reading. So, get to your readings. What I thought would happen at this point is I would do a presentation. But because I'm a little sick, I'm going to let you guys go first. I'm told that Alfredo uses a Mac, and this is why it doesn't work, because PowerPoint can't read PowerPoint. But I'm hoping that will change. Let's give him a, let's see what happens. That doesn't look good. You know, I got a theory about this. Yeah, we're not hearing it. That's bad. We can't get his talk. I don't know what to say. It must be possible to record something with a Mac, because he did this before. George, you use a Mac, right? Oh. I really don't know how to deal with this. And he's a distance learning student, so if we can't make this work, hey Alfredo, if you can't make this work, you're going to have to come to class. Is your Mac able to play his files, do you think? Can you access his file? Maybe you can't. You probably need a USB key. I don't have one with me. Alright, well, I guess we're skipping Alfredo's talk. That's too bad. There has to be a way. Is this yours, George? No, that's... What's this? A talk. You're giving the talk. Okay. Well, I thought we were going to try and give the talk without PowerPoint. Isn't that right?
Right.
So
I just gave you what I'm talking about.
okay. Yeah, that's fine. So since you've got this up here, would you like to go first?
Sure.
So it's cued. All right then. You have the com.
I mean, I had the, should I show up there or just put it down? Because I already have the printout.
Well, you're going to give a talk, right?
Right, correct. So,
So you can use.
all right, I'll just,
You can use notes.
all right,
Okay.
fair enough. Okay, good morning, class. I'll be talking about my thesis proposal today. The title is Plasma Radiation Shield. So to start off, I'd like to give you a background about what's this paper about. Basically, has to do with cosmic rays, radiation in outer space, and you probably know those particles as protons, alpha particles, gamma rays, and they're ionizing radiation, so they can change DNA and cause damage, and when you change DNA, sometimes that results in cancer because of the cells, they grow uncontrollably. Um, so on Earth, much of this radiation can be blocked by the magnetosphere, which is another way of saying the Earth's magnetic field. And basically, it's a dipole, so it has a north and south pole, and that blocks the majority of radiation. It's reflected back to space. However, on the other hand, well, this Earth, as I just said, causes cancer, but can also cause neurological damage, eye problems, etc. So it's not something, obviously not something you want to have. On the other hand, the radiation in outer space is much more, it's much stronger because first of all, it's much more spread open, and there's not as many. Spaces are much wider, and for example, the solar when the sun has storms, like it's called solar wind, solar flares, and they cause a big stream of radiation. And this, but in general, there aren't any magnetic fields to block this. So as a result, it's much stronger. And it's much harder to control. And this is also a major issue with NASA and exploring the solar system in general, because NASA has put a lot of money and time into trying to do manned missions, but because of this radiation, it's much harder. The spaceships can't block the radiation, so it's much more difficult to. It's very expensive. Because this is normally they've sent not manned mission in the past. I mean, that's what they usually done. But if they're able to get like mankind to the moon or to Mars, that would be a huge achievement. But this radiation is preventing that. So the solution, what I've come up with, is it's called the plasma radiation shield, and how it works is it's kind of a combination of the plasma shield. It's kind of a combination of well, there are three main types of shields that are used. There's electrostatic, the pure magnetic, and the let me see what else. And those are the two main ones. And this is a combination of electromagnet. Normally, the electromagnet by itself is not very practical because it has a very high potential, and it basically attracts the protons. This is what we're mainly focusing on, because the protons from the solar wind is the is the biggest radiation threat to these missions. For example, Mars. NASA is particularly looking to go to Mars. And so they're mainly worried about these protons coming from, or basically hydrogen atoms coming from the solar wind. But the radiation shield uses a combination of the magnetic shield and then the electrostatic shield together. But the electrostatic by itself will result, because it's such a high voltage, it will attract electrons as well at the end of the spaceship, and it will cause it's very high voltage, so it could be very dangerous. But when it's combined with the magnetic field together, they work much better. The way it works is that the shield, which surrounds the spaceship, the spacecraft, and it happens to be in a shape of a toroid, which is it's used, it surrounds the ship, so both the ship and the shield are in its torus shape, which is, as you probably know, it looks like a donut. And we use this shape because it has, it enhances the magnetic properties.
George,
Yes.
is primary thesis focused only on
It's basically it's focused on what I want to do is originally I want to start with a prototype, but eventually the idea is to block when on manned mission manned mission to outer space. Basically, it's not possible right now because there's the radiation's too strong and there's no way to get rid of it. And so you can't, because these trips will be most likely more than possibly a few weeks to a few months. So there's no way astronauts can go without being exposed to this radiation. I mean, there are obviously other types. I mean, like as I mentioned, the gamma rays, alpha particles, but because the solar it's called the solar wind, is when the sun has flares and that causes the release of this radiation. The protons is the main threat to because NASA's mainly focused on going to Mars, but obviously in the future, if this shielding works, they'll probably be able to go to more places because it's proven to. But that's why I'm not, obviously building a spaceship is not very practical. So I originally I want to start off with a prototype, because you can scale it and use equations of of the magnetic field and how it will affect the radiation. So obviously I want to start off small and then. And I mean, because that's the beauty of it, that you can start off. You don't have to build the huge.
So I'll take that as a
Yes.
yes. Okay. And so,
Yeah.
because non-magnetic shortwave photons can trigger genetic damage too at the atomic level.
Right, but
Protons
oh, yeah.
are there too, and you really focused on protons.
Well, yes,
But
because
protons will respond to both E fields and B fields.
that's correct. Yes.
So why not just use one or the other?
Well, I guess that's it. That's a good question, but because one of the advantages of having both B or magnetic and E fields or electric. I mean, I have both because the way, and then I also use for the magnetic field I use a superconductor, and I'm also looking to reduce the weight of when we build the whole thing, the full model, that you actually want to reduce the weight as much as you can, because if you make it too heavy, like if you put too many coils on the electric field, then and also actually the superconductor is the heaviest thing, and using this one coil, the magnetic field will have loops of wire around the torus of the shield, the shield that's shaped like a torus. But you also want to reduce weight by using just one superconductor, because it's perpendicular with the B field of the coils that are wrapped around the torus that are perpendicular to the axis. That will.
So how does using both reduce weight versus just using one or the other?
Well, because originally, so you have, first of all, you have the shield made out of aluminum, because it's a fairly light metal, is charged, has a really pretty strong positive charge, and so when the incident protons come in, basically because they're of like charge, that they'll repel each other, but at the same time they're also electrons. Electrons are attracted, of course, to the positive charge. To having the magnetic field, because normally the electrons would there would be if there wasn't anything to block them, they would be immediately attracted to the positive charge, and that might cause current to flow. But you also have the magnetic field that blocks the. It causes, and these electrons that are attracted are called, they're called a electron cloud, but they're blocked because of because they electrons can't flow through the magnetic field. Um, they will be they'll be kept away, and that will and the charge of the electrons will be the same as the voltage, the positive potential on the shield itself, and so they'll be blocked, and that's the idea, because it's using both. Because normally by these electrostatic shielding and by itself would not be very practical, and magnetic fielding, using magnetic shielding wouldn't be very effective either. But together, they combined, they actually turn out to
So using both is more effective.
effective together, exactly. Um,
So
okay.
is that supported by the literature, or is that your hypothesis?
It's supported by the literature, but they use different. They didn't mention how the you would get a charge to the shield, and I thought I'm not sure if you are aware of it's called a CW generator, and it uses it basically can produce a very high voltage using simple basic electronic parts like capacitors and diodes, and it multiplies the voltage. So it starts with either a
Oh, it's a diode doubler.
diode doubler. It's called a C. I read somewhere it was a CW,
Okay.
and that's how you would get. So they didn't mention how that would, and so I had to. But yes, the literature did support that. Supported that the plasma radiation shield. It supported that. Um,
So you're proposing that you have both an E field and a B field, and the literature supports that assertion.
Correct. To be more exact, there'll be the good thing about the torus shape is that you can control the magnetic field, but as I said before, you want to think about the weight at the same time, because that's ultimately what you, is what you want to do with the design. You want to be able to block the radiation from the protons, but at the same time you also want to make it fairly light enough to be able to launch. Not that, I mean, obviously with the prototype that's not going to be. It'll just be to see if it I mean, I would test it with devices to see how like a it would be tested first to see if it was actually effectively blocking the radiation, and you could use certain tools for that, like I don't know, a Geiger counter to see how much radioactivity there was. So anyway, I'm going to go to the so like I said, what's the advantage of doing this? What's the advantage of using the radiation shield? And basically, like I said before, using the superconductor means that you don't have to have, because that'll be creating the magnetic field. So the superconductor won't. You only need one to be effective. It would be wrapped around the toroidal shape, and it'll be perpendicular. It'll have coils of wire, uh, perpendicular to it to produce a magnetic field. And so using a superconductor actually makes it lighter overall. And then also using the toroidal shape makes it you can change the strength of the magnetic fields, which is also it's not you can't do that with the other shielding devices. And finally, the market. There probably won't be a very big market for this because it's limited to certain industries. For example, obviously space and aeronautical, like NASA. It's also there could be obviously a market in the health industry, because once again the main idea of this technology is to reduce cancer and other diseases caused by radiation. So, any questions?
So you need a proton generator,
Right.
and then you think maybe a Geiger counter can detect protons?
Mm, I'm not exactly sure. There might be. I would have to.
And how fast are the protons going?
Nearly the speed of light.
Very fast.
Very fast.
Oh, so you're not just generating them, you're going to need an accelerator.
Accelerator. So maybe
A linear
a
accelerator.
linear accelerator, such as like one used in a TV. Like a
The Stanford linear accelerator.
Stanford.
You'll have to go to the SLAC.
Oh.
Get some protons as they come off.
Right.
And normally they get reflected with magnetics.
Right.
But you're going to deflect them with a combination of magnetics and electromagnetic.
Yeah. Yeah.
How exciting. Who's next? Really good questions. Oh, this difference about reading, I think that's good. This feedback, you're reading this to the audience and getting to see what you read. So it's much better to be able to sort of internalize what you've written. It's not bad to write it out, but, and that's part of fun.
Right. Right.
But it might be bad to sort of read it. So,
And you actually
yeah,
recite it.
look, I think what you want to do is make a case quickly, like the elevator speech, which is what we were looking for,
Yeah.
a 15-sentence speech. I don't think that was 15 seconds.
I think that was very long.
It was very long. It's not like you were being tortured. And when somebody asks you a yes or no question, it's either yes, no, or I don't know. So I'll have to think about it when we get back to you.
Okay.
You know, I don't have to go on a tangent.
Yeah. Yes, I did a little bit.
We both know that it is. Not me, but
I'm sure.
Good afternoon, everyone. f- Before I start my presentation, I would like to say that there is like a small change in the topic. So previously we used fractal antennas for transmitting the power wirelessly, but there are some but I find out that there are some disadvantages, and it cannot be used for like transmitting the power at like high frequencies. It might be dangerous for the people uh, standing beside the antennas. So I was thinking maybe I will just use the concept of the Tesla using the copper coils for transmitting, but the concept of the Tesla is to transmit the power wireless using copper coils, where the both the copper coils are the resonant frequencies and both operate at the same frequencies. So there is a transfer in the power from one coil to the another, and from the second coil we get the equipment powered up. So recently I read a paper, and in the paper it cited that there are experiments going on where it's just not between the two coils. We just put the source coil at one place, and then we put the coil which we get the power at different places in the home. So by this we can like increase the range we have the same power output. There is no difference of what was done before. So there has been some modifications in the concept of the Tesla. We use the same concept, but there are like we are using like more copper coils at we put at different places, which power up, uh, which they get powered up by the source coil, and they transfer power wirelessly. So by this we can increase the range of the increase the range of the electricity concept. Uh, that was what I the information I got from the paper.
So fractals don't work at low frequencies?
It only works at low frequency. I mean, if we go for the higher frequencies, like very high, it would be like a dangerous situation for the surrounding.
Yeah, but what if you don't want to use a fractal antenna at high frequencies?
I mean,
Can't you use
we
a fractal antenna at low frequencies?
yes, we can.
So then what's the problem?
I mean, for example, we cannot like power up the system. We need some high power and high frequency, so it might not work for some equipments. It might work for some equipments.
The problem is it might not work. But it might work.
Yeah, it works, but it works, but it's like hazardous for the people
You don't want
surrounding.
to change your thesis topic because it might not work. It'd be really good to demonstrate that it doesn't work. That would be very
It
good.
it works,
In
but
fact, you could just say my thesis is to explore the possibility of using fractals. And if it doesn't work at certain frequencies but works at others, that's good information.
yeah, it works, but considering the ethics and the safety of the people, it is not such a good thing to do.
Well, maybe it works at low frequencies.
It works.
Not as well, but it's safe.
Yeah, at the low frequencies it is safer, but if we increase the frequencies at which we need to transmit the power, then it might be like dangerous for the people.
So why not just use low frequencies?
There might be some equipments which need which need high frequencies to like power up. I mean, for in industries, like there are equipments which need so much of power to switch on.
Yeah, it's one thing to talk about how much power.
Yes.
It's another thing to talk about what frequency. It's different.
We can use it with the low frequencies, but um, the like technique.
What happen if you use low frequency?
We don't have any disadvantage. I mean, it works. It works fine.
Is there low efficiency in low frequency?
Considerably
Considerably lower efficiency.
lower efficiency.
Why?
I did not get the information.
So if you were for high frequency and high efficiency, you just have to be very low energy,
What is it?
right?
I did not get.
What makes it unsafe?
Like the speed at what the electrons might transfer, or
Well, is there a regulation?
FCC.
Yeah. And doesn't the regulation have some sort of cap on power?
Yes, it does.
So why not just operate below that power cap?
Yeah, I mean it all depends on the environment where we are using it.
Depends on your application.
Yes,
So
application.
for low power applications,
It
will be
works.
fine.
It will be fine.
So that's okay. Nothing wrong with that. You don't have to power cities with this. We were thinking about powering small Atmel processors.
Yes,
Some of them
Atmel
take-
process it works.
Yeah, some take nanowatts.
Yes.
So that should be okay.
Yeah.
And then it's safe.
Yes. But at the same
So you
time we
have
need
change
to.
your thesis and just restrict its application.
But at the same time we need to consider like the efficiency. We need to improve, make some changes in improve the efficiencies because we are running it at low frequencies.
Well, why not run
So-
high frequency, low power to keep it safe, and just target biomedical devices with wireless power?
High frequency and
High frequency to make it efficient, low power to make it safe.
yes, that we can do. But if we do it at like high frequency to power up to get high power, then it might be dangerous for the people.
Well, sure. Nobody wants 100 watts of 10 gigahertz power radiating through their body,
Yeah.
so they come out medium well.
So
I'd say you can
the-
leave your thesis the way it is. Just focus the
High frequency, low power.
the thesis on areas that are safe.
Okay.
So you use low power, high frequency if that's efficient, and then use applications that work with low power.
Yeah, we can. There are so many
I hate
equipments.
to see you change your thesis in the
Yeah.
middle of the semester. It's shocking.
Okay, I'll keep the like the thesis part but it's just that I need to work only with the low power.
Okay.
Low power.
That's a good application.
Okay, but it only like power ups only small equipments like a microprocessor, a microcontroller, or
Maybe you can
biomedical.
power Ryan's yo-yo with Celerado. That's okay with me. There are things that go in your eye which can transmit images out to the image processor in your glasses, and then they transmit to an image processor on your belt. And they also put these things inside of your brain so that you can see. And these are implants now. They have to power the implants in your eye.
Yes. Yeah, those equipments might need like less power, where these fraction antennas are very fine, well and good. And coming to the market, I think there is like a broad range of market because of this advantages that we can power up the equipments, so the biomedical equipments, or in the medical industry, in the military, or at the home, like powering up the cell phones or laptops. It might be like very useful. So I think it has a very broad range of market.
Working with low power devices.
Hi everyone, my project is about calculating maximum power point tracking for the wind power systems. The present control units running for the wind power systems are not dynamic. They don't have dynamic characteristics. I don't say they don't have, but the dynamic characteristics can be still improved. Like most of the wind systems have TSR, tip speed ratio control units. Like approximately like 60% of the wind power systems are like they are operated with TSR units. This TSR units can be still can be improved. Their dynamic characteristics can be still improved with the hysteresis control, adding hysteresis control to it.
Okay, let me stop you right there. There are three things we wanted to touch on. Pain, the advantage, and the market. So tell us about the pain.
Pain is that
What difficulty, what pain are you trying to address?
it's to improve the efficiency of the wind power system.
So wind power systems are inefficient.
I don't say that, but their efficiency can be still improved with this hysteresis control. Because energy cost can be reduced to some extent. Advantages, I can say, it's like as I said, 60% of the wind systems are operated with this TSR system with just a control unit. uh, the efficiency of the wind system can be improved. Not there's no need to change a complete unit. Just a control unit can improve the efficiency of the system. uh, that's the advantage of this. And talking of the market, it's not a consumer product, so I don't say it has a good market, but it can be, this control unit can be simple and can be installed very easily. Not just like because I'm not changing complete power system. It's just a small unit that can be just installed in the present running systems. So 60% of the present running TSI units can be upgraded with this unit. So I don't say it has got big market, but still this idea can change the efficiency of the present running TSI units.
So what is the sustainable competitive advantage? Are you offering this for free?
No, I mean actually
Why can't I just copy your idea?
I don't even know will this click out, because I don't have any experimental values that this is efficient and all that, but this is an idea I got. But
Well, if the idea pans out, is there something patentable here?
yeah, because there is no wind power system which is operated with this STS and with TSR using a microcontrol switching.
Pain is you're going to improve. People aren't as efficient as they should be with their operations for wind turbines, right?
Yeah,
And you're going to make them all more efficient.
I'm not sure. I don't have any. As I said,
Well, that's what you want to do, right?
yeah, I don't have, I don't have any experimental values for this thing. I need. Uh,
Well, that's another question. Are you going to build this as part of your thesis? Are you proposing a construction project to gather data?
so maybe I'm proposing a construction project.
Or are you proposing that you simulate the whole thing with computational fluid dynamics and wind turbines in the computer? How will you get your data? What methodology will you use?
Yeah, simulation, taking a small wind turbine,
So you're going to
simulating it.
simulate it.
Yeah.
How do you simulate a wind turbine?
I'll create a closed environment where air fluids, where I'll blow air using air blowers.
Wait a minute, how do you simulate a blow?
It's like some with blowers, like heavy blowers. We have vacuum blowers, or how usually the aerodynamic simulations.
Do you have software for this?
No, I'll just run the turbine with the different speeds.
So you're
And with-
actually going to do an experiment.
Yeah,
You're not going to do simulation. You're going to build a prototype.
yeah. It's like I'm not.
Well, it's one or the other or both. So are you going to do simulation and build a prototype?
Yeah, maybe experiment. Yeah, it's experiment. I'll do an experiment on this.
So that's your proposal. You're proposing to do an experiment.
Yeah.
And from that experiment, you intend to have some experimental results which would validate your theories on,
Yeah.
on efficiency prediction.
Yeah.
Okay. I couldn't get that from your paper. Because your paper didn't say, this is the methodology, here's the approach. I'm going to build this thing. There may be computational fluid dynamics software that you can use, like Nastran. You could simulate the whole thing with the computer. That's legit. And why not? Simulations are okay. But if you can actually build it, then you have to create a prototype.
Yeah.
Small scale prototype. You can operate it in the wind tunnel next door. We have a wind tunnel.
Right.
So you're going to build something and put it in the wind tunnel. That's very exciting. And you're going to control it with the computers, right? Arduinos. And maybe quite quickly.
Yeah. I'm just taking the details of the wind turbine. I'm not actually doing some aerodynamic stuff with the wind turbine. I'm taking the details like output voltage, output current, that wind speeds and all that.
All right. So next time I see your proposal, you're going to describe what it is you intend to build, right?
So I'll try. Yeah.
Well, I mean, I'm just asking a question. If you don't want to build it, how would you validate your theory? I mean, you just got through telling me you don't have experimental results. Maybe the goal of your thesis is to obtain some.
Yeah.
Maybe. Otherwise, why do your thesis? Maybe the results are all simulated. That's okay. But if you want to build it, that's good too. I can see this being an interesting build project. But you might like to do some simulation.
Yeah, I'll try it. I'll try to
Maybe MATLAB
get some.
can simulate it. I think they have a toolbox for that. If they have computational fluid dynamics, they're good. They know it. Yeah.
I don't know. I'll search for that simulation softwares and I'll try to.
Sikorsky doesn't just build helicopters, they simulate them.
Yeah.
They have big things. What else? That it?
That's it.
Okay, thank you. I think you guys have to take it out.
My project is about energy monitoring, and when we talk about the pain, electricity is a not a renewable form of energy, so they need to save power. And nowadays, everyone wants to save power, and for that, we have so many monitors to see how much power each one is consuming. But they don't have any monitor, not exactly don't. They any monitor which gives us exact details of how much power is consuming each and every time when we use it. Like in the standby mode, when we unplug it, we don't know how much power it is using. So this meter, this energy monitor, it will help you to give all the details about the power, even when it is in a standby mode, and sends all the and transmits all the power values. And with this, I think people can they use electricity in a controlled way and lower their bills, and it also helps in consuming electricity. And this gives us energy costs to our attention on a regular basis. And about the market, I think everyone wants to save power, so I don't think it will be a problem for this. That's it.
So,
I, I was thinking about it. So,
Is there something here you can add, do you think?
I think maybe the continuous transmission of values. I don't think nobody has. I think nobody has patented it till now. So maybe because of that.
Well, we sent
We,
a
the,
link out today about values being transmitted using
yeah, but everything we have to connect outlet. We have to connect an extra outlet for that. What I'm telling is like we can build an outlet so that it automatically senses all the details instead of using another device to calculate the power. We can just integrate everything in the outlet.
So it's a microelectronics packaging innovation. Is that what you're saying? Outlet integration?
Yeah, instead of every time using plugging it and unplugging it, we can just integrate everything into an outlet so that when the computer is plugged into the outlet, it will tell us all the details about the power. Like when we switch it off, we don't unplug the device. So all the but still it is consuming some electricity even in the standby mode. So we can know all the details about it.
So what would the claim of the patent look like?
Maybe new outlet,
An integrated outlet?
something like that. Yeah.
I don't think anyone else has done that.
I think so. I didn't check it till now.
Okay,
Yeah,
very good. Thank
that's
you.
it.
So Akshay, you're up.
Okay. Uh, Superconducting motor at driest temperatures. So the pain is like we already have motors that work at that work with superconductor. I mean not superconductors. Like yeah, we can use superconductors in motor. We already have that motor, but we haven't uh, availability of superconductor motors that works at driest temperature. So this is the pain we can we can have a motor that works at driest temperature too by using superconductor. And advantages of these motors, we can use these motors in navy applications and space applications. As he George George's experiment, we can use those motors in space applications. And because of this low weight of superconductors, we can use this motor in applications of like that works in cold countries, very extreme cold countries. And coming to marketing, uh, this one has a, I can say that like we can use this in navy and space applications. So uh, marketing is good for this one because of low size and cost. And uh, I based on my search, I found out like neodymium motors. Uh, Already we have neodymium motors. Those are permanent magnetic rare earth magnetic motors. The working temperatures of the, I mean, neodymium magnets works they produce magnetic field in the temperature range of minus 40 degrees centigrade to 165 degrees centigrade.
Minus 40?
Minus 40 degrees
I
centigrade.
thought they could go colder like minus 70. Is that what happens after minus 40? Do they lose their potency?
Yeah, they lose their magnetic field with, I mean,
So,
outside
so,
that range.
so does CO2 destroy neodymium magnets?
that's what I was searching for. I was searching for the motor. I mean magnets that works at driest temperatures. I mean
But my question is very specific. If I go to the store and buy dry ice, and put my neodymium magnets in, will they stop working?
neodymium magnets. The, someone did research on this. They don't lose magnetic field in the CO2. I mean driest.
So
They don't lose it, but it spins in the different directions.
Okay, I can live with that. So basically,
So the
neodymium magnets
magnetic,
work in CO2.
yeah, magnetic field decreases 14%.
40 or 14?
14%.
Okay, that's all right.
So
They're very strong.
I was thinking we can use that neodymium magnet at driest temperature with I mean compared to less magnetic field.
That's good. Neodymium magnets will work.
Work at driest temperatures, yes. So first I was thinking to produce the superconducting magnet that works at driest temperatures with the research going just went off with the researchers. It's a 1256 by 1212 structure, but we can use neodymium magnet at driest temperature. So I was thinking go to with neodymium magnet.
So I think the sustainable competitive advantage is that nobody else has a minus 70-degree motor, dry ice motor. So that's a big advantage. You're the only one. Only game in town. And then we can use standard neodymium magnets. We've already seen homopolar motors work. So all I need now is to identify material that can be cast into the shape of something that can be
Used
as
as a
a
magnet.
homopolar motor.
Yeah.
And then I can build a prototype to prove concept.
Yeah, but we need to gather all the information about the torque and speed characteristics.
Yeah, how do I get dry ice temperature wire formed in that shape?
Yeah, it's we
It's
can
not
convert.
technical.
We need to convert superconducting. I mean, this magnet to wire to produce a motor, like to use in windings of the rotor and stator windings.
I'm very excited. I think we should build this.
Oh my god.
I think this is very exciting. We have to identify where we can get the materials for the 70-degree temperature superconductor. If you can find that,
Yeah,
it's
I'll definitely search for the.
search for it, please. So we can buy this with the research money. Very good. Thank you. It's very exciting, isn't it? Building a motor nobody else has. That's great. You can license that technology. That's a great way to.
magnetic field is decreasing when at the driest temperature. When low temperature, cryogenic temperature.
I have a feeling that the energy that comes off of the battery will also decrease when you put the battery in the dry ice.
Yeah,
The battery will probably also not work very well. So that's another problem. So when you start operating at that temperature, how are you trying to dry ice battery?
we need all the equipment that works at driest temperature.
If you use an alkaline battery and you run it at minus 70 degrees, the alkaline will freeze. I don't know. Salt water will freeze. Acids, a lot of acids will freeze. I don't know what's going to happen. You take a battery, put it in the freezer, it might work for a while, even though it's frozen. If you put it in dry ice though, we could try this with a Duracell or with some kind of alkaline energizer. Let's see. I think that's very interesting. So we could, dry ice is cheap. We can get that.
Very interesting. Actually, that neodymium magnet.
I already ordered. telling. You can use those to build your thesis. And if you don't, then I'll display it. So I have a feeling that you'll enjoy these neodymium magnets. If only we could find some superconducting wire in the right shape. Your job. You have to find that. All right, so let's stop this for now. Take a little break.